Good afternoon, all. Welcome to the afternoon session of the third day of the AICTE sponsored short-term training program on IT solutions. I hand over the session to Dr. Balaji. He'll be introducing.
Thank you, Deepa ma'am. It's once again good afternoon to all the participants. So before beginning of your afternoon session, so we have today we have a two eminent person who's going to enlighten you the knowledge about the IoT in the field of health science and various methods. So it's my pleasure to introduce your first speaker today for the afternoon session, Anish. So Anish is an young and dynamic engineer who has completed his ECE in the Angel Institute of Technology and Design from Goa. And he had a reputation of making up an impactful recommendation for manufacturing of printed circuits boards and certified power designer from Texas. And he has received several awards and honors from the government of Goa. And also he's not only an academician or is not only a trainer or not only a designer, is also a shooter, and he has got various prizes from National Rifle Shooting Championship, and he is supposed to be one of the gold medalists in the championship which has been conducted in the state. And apart from this activity, he has been one of the integral part in developing the various robotic projects in terms of your IoT, augmented reality, virtual reality, 3D printing, and this list just keep on going on. And with this a short statement, it's my pleasure to welcome you, sir, Mr. Ajay Motkar, sir. And the second guest who's going to be there will be giving you a session is Mr. Ajay Kumar, who's supposed to be one of the passionate speaker all over across the Tamil Nadu, and he has a master's of degree in computer science from PhD Tech, and he's been the one of the major pillar activity of setting up a various smooth transaction between the colleges industries. It's across all over the Tamil Nadu, and he has been had a responsibility in setting up campus connect from PhD Tech to the various companies in which the young engineers have been getting recruited. And apart from this, he is a passionate for your Toastmaster, and he has a good leadership and the various competitive experience. And is right now is working in the Divya as a head of software solution. So with this as short introduction, it's my pleasure to welcome you, sir. And I'm giving a hand over the session to you, sir. We'll look forward to your statement.
Sir, can you please confirm if you can hear me?
Yes, sir, I'm hearing you, sir.
Okay, so I will need to drop off and come back, sir, because my screen sharing is disabled for now. Okay, so give me 1 minute for that.
Okay, sir.
Thank you. Yes, sir. I hope you can hear me again.
Yes, sir. I'm hearing you.
Oh, yes. Okay. So I think I'm good to start, right? Yes. Okay.
Yes, sir. So, you can go ahead.
Thank you. Thank you. Hello, everyone, and good afternoon. I know you have been listening to a lot of talks on IoT, healthcare, and all that. So today what I'm going to do is I have a few applications of IoT which are applicable in the healthcare industry, and also some things that might come in the future. So I'll be sharing those with you. And also if there is time, I will take you through a very simple idea of how you can do your own IoT solution for a healthcare industry. So this is not something like very complex, like you will need to go purchase a system or no such thing. It's a very simple thing that you can do on your computer. If you're on the computer, you can try it out with me. Okay, so we'll do some hands-on as well. Right. So let me share my screen. Can you see my screen, sir? Can someone please?
Yes, sir, it's visible. Yeah.
Okay, awesome. Thank you. Right. So again, welcome to DIA. We are DIA Do It Yourself Academy. So our founder was the one who was presenting the session yesterday. It was Mr. P. Uday Shankar. And today's session, it will be by me. And if time permits, Anish will join us. So the how the flow is going to be is I'm going to take you through various applications in healthcare that have been achieved or that are possible through IoT. So I'll be sharing some videos as well that have been either technologies that are in place today or something that is proposed for the future. So one such thing is how I want to start my presentation with. Right. Let me minimize this. So the first discuss remote that it might be a little simple that you can make a phone call, talk to your physician or talk to your psychiatrist, whoever, and do your health checkup over there. But what we are going to talk about is something that is not possible for a patient to travel to the hospital. What do they do in such cases? Okay, there is a solution already available in the market. So I will share that with you and then I'll go ahead with my content. Okay, please. So is the audio coming? Can you please confirm? Sir, are you there?
No, sir.
Audio is not. No, when I was playing here, does the audio come now?
No, sir.
Okay. Is there something special I'll have to do for that?
Sir, when you're sharing, you just include along with system audio, sir.
Okay.
So you can stop sharing now.
Okay, and then?
So when you start sharing, so we'll have by the left side, you can system audio there. We have to include the checkbox has to be included, sir.
I only get this small box. I'm not getting this.
So you're using, okay, no problem.
Okay, let's see if it comes now.
No audio, sir. Because system audio is not included, so that whatever audio is it is playing at the background may not be audible through MS Team.
Okay.
So since you're using a web, there will be a
Oh,
problem.
no. I'm using the app only, not web, sir. That's all.
Okay. So if it is app, by left side you will have when you're sharing your screen, you will be finding an option of include system audio option will be there, sir. Sir, I just ask you a control. Can you give me a? Yeah.
Please, yeah.
So can you just stop sharing, sir?
Okay. Now can you take control, sir? Is it?
Okay. Yeah. Now just press the share button.
Okay. Open share tray.
So just find the left side corner, sir. Left side corner of your screen, you will be having your option at the radio button at the top, like include system audio.
No, sir, I am not getting. It's fine. I think we can manage. Not a problem because I'm not getting that
It
option.
will be like include computer sound. That is either include system audio or it will be include computer sound. That option will be there, sir.
Okay, give me 1 second. Let me see if there's
Okay.
something. Sorry for the confusion, everybody. Sorry. No, sir. I think we'll go ahead with not like without the audio then. Okay, that shouldn't be a problem
Okay, sir.
because it is only a 2-minute video, and then I will be the one. Maybe
Okay, sir.
I'll talk along. Okay, we'll go ahead. Okay, so you can see the subtitles over here for the entire video. If there is any question, I'll take it. Okay, so as you had seen in this video, this was a solution offered by Philips, the company Philips. Let me break it down for you. What has IoT to do something in healthcare industry? Okay, now we have a lot of in the healthcare industry. You start with the patient's data, patients, vitals, patients, condition, patients, age, lot of data. Then you come to the instruments. There is again a lot of data: instruments, wear and tear, instruments, condition, so much data. And this all of this data might not be useful for only the hospital that you visit to. Now think of the hospital that you visit to at your home or maybe at your home place. This hospital might not have the facility to process all of this data and give some results. That is where IoT comes into place. So you put all your data in a cloud or a place where everyone can access the data and provide comments to it. So that is the basic concept of IoT use in healthcare. Now let me take you to this very specific example, which is remote health monitoring. Okay. So this was a solution which was developed by a research student from Japan, and mainly it is targeted for elderly people who are not able to visit the hospital. So this problem that they're trying to solve is for respiratory problems. So there are a lot of elderly people who are facing trouble with their lungs. How can they, without going and without visiting the doctor, how can they try to cure it? So this is the small solution that is prepared or proposed by them. You have your clothing over here and a small signal acquisition unit or a unit that reads your respiratory data and sends it over the internet to the doctor is placed here. And this will keep continuously monitoring and sending the data to the healthcare physician or the doctor. Okay. So even if the patient, let's say tomorrow has some issue, the doctor will be able to see from the hospital only what kind of issue the patient has, what kind of solution he should give. Everything is done remotely. And that is why we call it as remote health monitoring. So this is a research, the data that I have taken here is from a research paper produced in Japan. The next thing that I want to talk about is critical hardware. Now we see a lot of equipment like ventilator, ECG monitor, and all those things where the equipment is very, very crucial for a patient's life. For example, if you stop a ventilator for maybe a day or so, the patient might not survive, right? And what the other problem that we have on hand is, if at all the ventilator has failed due to some reason, or maybe there is a power failure, something like that, then what happens to the software? That is the question we have on mind. And the solution that is proposed by IoT for this is you monitor the health of the devices by just having a small sensor over there. So what the sensor is going to do is it is going to look for all the wear and tear of the device, the correct power incoming or power consumption of the device, and also the condition of each and every part of the device. What it is going to do it is it's going to keep periodically sending the reports to the staff. And how they can or how they take care of emergencies is, if at all any small failure occurs, immediately the patient, I mean the hospital staff or whoever is in charge, the doctor over there, should be notified. This is a very simple solution that is developed, and the technology that I am referring to is called Philips E-Alert. And again, how this can save or this can help the healthcare industry is, first thing is reduces costs. Now, how it reduces cost is, you might or you can be, even before the instrument is going to fail or even before the instrument is likely to have a failure, you will know because of your continuous monitoring. So, which can lead to easy fixing of the instrument. So you don't have to replace the instrument after it is gone. And also critical things like you can save lives. That is about hardware, where you can fit sensors to monitor hardware using IoT. The next thing that I want to cover is sensor enabled pills. You might have heard of this concept. This came back in, I think, 2015 or so, but it has not been so successful because of some reasons, but we'll ignore them for now. Let me tell you the concept behind this. We all have small pills or tablets that we take. What if you could fit a very small sensor, maybe the size of a grain, as you can see here, inside the pill and swallow it? What happens in that case? Now, this small sensor, whatever we are swallowing inside our body, it is designed to keep continuously monitoring the patient. What kind of data that it's going to monitor is, first thing is your digestive patterns or your digestive reaction to each and every kind of food that you eat. The next thing is, maybe if there is an issue with your respiratory organs or something like that, it is going to monitor that. And how can the doctor access the data is, this data will be continuously sent over internet to a cloud from where both the patient and the doctor can use it. The patient will be having it in form of a phone app or something, so you can continuously see what is going on inside your body. That will be something nice to know about what is going on inside. And also the doctor can see for so they can know what kind of diagnosis to be done, what kind of treatment is to be done, and how to save the patient if at all there is some issue with the patient or some sickness like that. So these are pills that you take and they stay in maybe for a frequent amount of time, something like that. There is one more version of these pills which is called diagnostic pills. Okay. Now I'll share a small video. The audio is not very important, so you can ignore it. And you can only take a look at the photos or the images that the video has. Okay. So this is again a technology that has been done successfully. What you're seeing here are images of the patient's body. So this is through a pill. Okay. I'll show you more. 1 second. So this is the pill, as you can see here. This is how it works. Now, let me tell you, or why or in which case these kind of diagnostic pills are used. Let's say you have a problem in your intestine or something that the doctor wants to look at. The typical solution that will be proposed by a doctor is endoscopy, obviously. And endoscopy involves you open your mouth, put a tube inside your mouth and see where the flaw is inside your body. But endoscopy might not be feasible for all cases. For example, if the patient is unable to allow the tube to enter inside, or maybe if the wound is somewhere that the tube cannot access, then that is where this comes in handy, which is called a diagnostic pill. And as you can see here, this has a small camera to it. And these small white things that you see are flashes. So what the doctor will do is, the doctor will give you this pill and you will swallow it. For each and every minute that it travels, or each and every second that it travels inside your body, it will take close to 500 to 1000 photos for each and every second. So by the time it has reached your intestine, it would have taken roughly maybe 10K photos or so of each and everything that the camera sees. So the doctor will continuously be able to, I mean, you put all of these photos in form of a video, the doctor will be able to see your entire journey from starting from your mouth all the way to the intestine. And the doctor will have the idea of what or where to look and where to give the cure for. And again, this pill is, I think it has an expiry of 24 hours or something like that. So it will be excluded. It can be, again, sterilized and reused as well, because these pills are a little costly. So these kind of diagnostic pills will be reused. That is how this thing works. Okay, I think I'll pause here for any questions so far before I proceed. If someone has a question.
So please continue, sir.
Oh, okay.
Yeah.
We'll take questions at the end then. Okay, sure. Okay. So you were asking, okay, I think it's right. Yeah. Okay. Okay, now these pills and all those things. So pills or something like a wearable that can be used only when you have a sickness or when you are needed to go and take a treatment, right? What about the wearables or what about the fitness devices that we already have in our hand? Best example is a smartwatch. How many of you have a smartwatch here? I think at least if there are 40 people here, at least 15 people would have. So what I'm referring to is something like a Fitbit or something like a MI tracker or Apple Watch, anything like that. So those are wearable fitness trackers or smart health watches. And what data that these devices can give is, first thing is heart rate. So you might have seen there are apps that measure your heart rate and tell you, hey, you should take a break, something like that, right? Calories burned. So each and every step that you take on your daily life is monitored because of the motion sensor. So how it works is, let's say if this is my smartwatch, this is actually just a watch. This is my smartwatch. It has a motion sensor to it. So if I move my hand like this, something like this, then the sensor is going to send the data that I am walking. Of course, this can be like misleaded by just moving the hand, but let's hope that we are not doing that. So that is how you can track these two things: calories burned and steps walked. So just by hand movement, your watch is able to track all of that. Then blood pressure. So there are some recent sensors that have been come in Apple Watch 6, if anybody has seen that video. It is called an oxygen sensor. Okay. What it does is it would look at one particular nerve here and it will look for the oxygen level in that. I'm not sure if it is 100% accurate because it is ideally supposed to be measured here. But to a certain level, the sensors are accurate. Then it can measure your sweat, obviously, because it is on your hand. Time spent exercising. This again is through the motion sensor. If there are any seizures or something like chuck in your body, that can be measured as well. Finally, the respiratory data. This is very, very important. This is very nice to measure actually. So how the respiratory data is measured is the watch or the band will ask you to hold your hand like this. And what it is going to tell you is it is going to ask you to inhale and exhale. Inhale and exhale. Continuously, you have to do this for 5 minutes, I think. 5 minutes. With this small exercise, your smartwatch will note down the entire pattern of your oxygen flow, like you're inhaling and exhaling, and it will tell you how your lung system is. So these are all forms of data or what kind of data that your wearables can give you. Now, what does this help me? You can ask, or what? How does this benefit me? How does this use? Okay, the answer to that is, oh, okay. There is one more device I want to cover before coming to the answer, which is called Body Mass Index Scale (BMI). I think everyone knows what BMI is. It's a value that is derived from mass and height ratio. So you can easily categorize if you're underweight, normal weight, overweight, or obese. So this sensor, if at all you have seen, I think it is around 7 or 8K on Amazon.in. If anybody is interested to buy, what the sensor will have is only a weighing machine, nothing else. And there are advanced, like costlier sensors which can measure your height as well. But we'll only talk about this. So you stand on the sensor and your weight and also some other things like, for example, your diet, you have to feed in through the smartphone app. This sensor, it is going to see your weight after each and every meal that you do. So let's say you're eating 3 times a day, you have to stand on this machine for 3 times a day. And after each and every meal, it is going to calculate your weight and also the pressure that you have on your legs and also the input that you feed in, for example, your diet. And it is going to monitor your diet pattern continuously. You might be thinking just a small weighing scale, but it can go to the extent of measuring your diet pattern continuously. Now, what do we do with this data? Again, IoT comes to the rescue. You have a lot of data in your hand. What do you do with it? The solution that I'm going to cover is chronic diseases. Okay. Now, what are chronic diseases before we get into that? Chronic diseases are diseases that might occur repetitively for a person. For example, let's say there is a small headache and the person might get headache once a month. You don't know why it is happening. Or something like shoulder numb. Again, it might happen at not a frequent interval, but sometime inconsistently as well. And if you're not sure what to do or how to handle these diseases, the data that we have using the smart watch or using the BMI scale can help you. How this is done is these healthcare devices like your watch or your BMI index, they monitor your data on a daily basis. So each and every day it is recording something, right? It is recording, for example, your footsteps or for your diet pattern, something like that. So these are examples again. Smartwatch can monitor your daily footsteps and weighing machine your daily diet effect. Now, what the doctor is looking for is this data for a long time, maybe 1 month or 2 months or 6 months from the day that you bought your smartwatch. If you consolidate all the data and if you put it in form of a report, then the doctor or the physician can look at that data and he or she can recommend solutions for you. So, for example, let's say I'm having a shoulder pain for me, and the doctor looks at my smartwatch data and he or she says, hey, for continuous 3 weeks or 4 weeks, you have not done any exercise because the smartwatch has not detected it. That is the reason you are having shoulder numb. That's a very simple way of putting the data. These actually, we have seen one or two examples live so far, like smartwatch saves lives. You might have seen articles like that. But what the IoT industry promises is that over the long term, like going forward, maybe 2, 3 years down the line, your smartwatch devices data will surely help you in addressing very frequently occurring diseases to you or problems in your body. That is what the industry is promising it to us, but let's see what happens. Okay. Right. Next thing is remote surgery. We all know surgery that happens in rooms like operation theater. So a doctor is there, he or she performs a surgery. But your operation theater or your hospital, where the city that your hospital is located in, will surely have restrictions. Like it cannot have all the possible equipments in the world. What if you need an expertise from a doctor who's sitting thousands of miles away? That is when the concept of remote surgery comes into place. What remote surgery aims at doing is, as you can see here, the doctor will have a screen or a way that he can connect with the operation room, and he or she will have a control, like this you can see here. They will monitor all of the devices. Now you see when this doctor is about to move this small lever will move. It's not a video, but I'm just showing you. I saw the next picture as well. So the doctor has his virtual hands, that is what we call it in IoT, virtual hands on the patient or on the victim. And he or she will perform actions over here on the computer, which will indeed be replicated as a real surgery. Now, there are few requirements for this, like you might have obviously thought about it, which is very high speed cable connection or internet, as we call it. You cannot rely on something wireless for remote surgery because if at all there is a failure, then it is going to be very, very critical. It's going to be a patient's life, right? So if those settings are in place, then remote surgery is surely possible. And this is one of the operation that had been done back in 2001. So this was a date, and the operation name was Lindenberg. This was a doctor, a female doctor. She was operating from France in Europe, and her patient was in New York. So it was across the Atlantic Ocean. You know how big the distance is. This was the very first successfully conducted remote surgery in 2001. So this photo is again not of that. It's another one that I'll share with you. So since 2001, this concept of remote surgery is there, but it's not a very frequent one because it's obviously very, very costly. You can't afford to make a doctor work at some other time, and also the physical uh, requirements for remote surgery are a little high. Now, there is one more question on people's mind that if remote surgery is possible, why not have robots do the surgery? Because the doctor is just going to do something, and if you can program that to a robot, why can't the robot do it? You can remove the doctor, right? There is certain research going on for this, but no such robotic surgery has come into place as of today. So I thought I'll just share that with you. Okay. Let me see. Right. Um, Now, there are certain technological advancements that we have seen in the technology world that have been caused or that have been created because of a requirement for IoT in healthcare industry. Okay, I think I did not clearly say that. I'll tell you a good example. Okay, when performing remote surgery or when attempting remote surgery, there are certain challenges that might come up. And to solve this challenge, solutions have been developed, and these solutions are very popular in the tech world, as we all know it. One such solution is force touch or force feedback. You might have seen things like this is actually Apple AirPods Pro. If you force press or if you press your device at a very harder, let's say, pressure, then the device will respond. Now, what was the challenge back in the healthcare industry was when the doctor is doing a remote surgery or something where they're not in person, how do you know how much pressure you should apply on a wound? Or let's say you're performing an incision, something like that. How do you know how much pressure should be applied? And the solution for that is force feedback or force touch. Now, this is actually seen in some phones back in 2007, sorry, 2015, if I'm not wrong. Apple phones are there, and there are some Android phones as well. If you press your screen harder for a small, like if you give force and press the screen, then there will be some action triggered. So this is a solution that was developed because of a challenge in the healthcare industry. And the next and most important challenge is depth perception. So let's say the doctor is operating on the brain or something. How do you know how far you should go? If you go, let's say, 1 inch far, like internal inside, it might cause fatal issues because it's the brain, right? So if something like this, as you can see this image, if the doctors can all see the 3D perception of the brain, then it will be easy to solve this problem. And that is where the technology called 3D vision or binocular vision came into place. Now, how this works is, let's say there's a patient on the bed. The patient's camera, in this case, because we want to see the brain, the patient's head will be surrounded with your scanning devices like MRI scan or whatever scanning devices in the form of cameras. So they'll be fixed all around the brain, and they'll be recording images of all layers of the brain. All of this has to be consolidated again through IoT, and this shows you a visual like this, like a brain or whatever the organ that you're trying to look at. Now, where you might have seen this in the technology world is 3D construction, like in civil, you might have seen 3D projections of buildings and all those things. Those were all because of this challenge in the healthcare industry. Again, 3D games as well. Games actually came before that, but 3D vision of objects. That is how this technology came. Okay, right. So there is one more interesting thing called psychiatry. Psychiatry is, as you know, the study of your the internal thought process or moods, for easy understanding, of a human being. There is a solution proposed by a company called Think, THYNC. Now, what they say is, I'll give you two sensors or two small devices that you can put on your specific parts of your brain, sorry, on your head. What these sensors are going to do is there are four types of brain waves, as we all know. The one particular type, I think it is alpha, it is going to send only alpha waves to your brain. And these two sensors, as I mentioned earlier, are called calm and energy. So what the calm sensor is going to do is, if at all your body has stress or maybe some tension kind of thing, it is going to send waves that will help you calm yourself down or relieve stress. And similarly, the energy sensor is going to help your brain recharge itself or maybe get ready for the next upcoming one. So this is actually available on Amazon, but it's not a product that is being sold right now. You can see that it is. They say that it is out of stock because this technology still has it's in the funding process or funding phase. Yeah. So this was something about psychiatry. So you might not think that IoT is only used where physical equipments are there or something like the patient has to be there for surgery, something like that. Even if it is something to do with something that you can't see, like psychiatry, IoT can be used in the healthcare industry for that as well. Okay, so there is a small, I think we have time. I'll take you through that as well. Before that, again, any questions? Or you want questions at the end, ma'am? How does it work? Um, one sec, I think there is. Okay, I think there is one question. Yeah. It shows that we have security for the data is provided. IoT is subject to security attacks. Yes. So I would like to answer this question again back to what our founder Uday was mentioning yesterday. There are a lot of risks in each and every one of these technologies proposed. Like, for example, you take the pills that I was talking about. If at all one particular pill has a fault or something, then it is again a problem. And similarly, the as you know, IoT, this data is stored on a cloud. So obviously, security has to be taken care, as mentioned by Uday. But if it's not taken care, then the data is available to everyone around you. So let's say you're a superstar or you're someone like a very important personality, like the CM or the PM or the president. If your data is monitored and if your data is available on the cloud, and someone has access to it, like someone who wants to do some harm to you, then that is a very big challenge. Like they know what kind of pattern, what kind of diet you're going through, they know what kind of sleep pattern you're going through, and if they want to do something harmful, it is a possibility. So that is a very big challenge. So that is why security in IoT comes hand in hand with the developments that are going on, which is why most of the equipments, to be frank, have not yet come out, because every equipment that I was talking about or every technology has its own proof of concept. Like people know what should be done to get this all run or get this on the road. But why it has not been approved is because of security. The government still do not trust maybe a research paper enough to provide funding. It is a big challenge. Um, Anything else? Okay. So, ma'am or sir, do people have computers? Like, I have a small hands-on thing if people are having computers. How many of them have computers? Mm, okay. So let me just share and I'll paste the link on chat. If you have a computer, please open this link and you can help us or you can play along. Okay. We'll do it that way. Nice. Okay. So again, I'll reiterate what I was saying. You might be thinking that IoT in healthcare is only for people in hospitals or maybe people who are very, very tightly associated with the devices over there. But no, IoT can start at a very small element like a child's coding or something like a programmer sitting on his computer and writing something that the user will, like someone who goes into the hospital website can use. So that is one example that I'm going to show you. So if you have access to your computer, please open this link that I have shared. What we are going to do now is a very simple application called a chatbot. A chatbot, as you all know, is a bot or an automated process that will respond to the user's query. Where you might have seen this is if you go to book a train ticket, IRCTC, or flight ticket, you might see, "Hi, where can I help you?" or "How can I help you?" And if you type, let's say, I want to book a ticket, it is going to give you some way how to do it, right? Yes, yes, yes. That is one good example as well. Very good. Right. So I'll show you how we can develop, like you don't need any expertise or anything to get started with IoT. That is what I'm trying to convey. It is as simple as you have a laptop and you have some time. Nothing more than that is needed to get started with contributing to the IoT industry. Okay. So let me first share my screen. And if you have a computer again, please open the link and please try to do it along with me. Okay. Okay, so again, there is no audio, right? It is fine. Okay. Okay. Now, this is a very small application that we have developed here at DIA for COVID testing. For COVID testing, okay. I'll show you first what this does, and then I'll come to the code part of it. So it is first going to say, "Welcome to Healthcare Assistance." It is asking my name. So it thinks that whatever I say, my name is my. Then it is going to ask me, "Please tell me your symptoms and actions." So if I'm having COVID, or if I'm going to ask the computer, "Hey, do I have COVID?" What I'm going to say is, let's say my symptom is something like fever. And it's going to say, "It's a symptom for corona. Please go for COVID test." But if I'll do it the same thing again. If I type in something else like Ajay, it's asking my symptoms. So I'll go for the second one. I'll say I want to do an action. So the action that I will do is I am wearing a mask. Right. I don't have a mask now, but please forgive me. If I have a mask, then it would say the result for corona is, or COVID is, negative. It's a very, very simple thing. You might have seen this kind of assistant in a lot of websites, like IRCTC website had it, then flight booking websites had it, all those things. I'll show you how to do that or how to get started with that. Okay. It is very, very simple. So if you are having a computer again, please open the link and please try to do it with me. Okay. So this small bot that you have here is our hero, or is our assistant that is going to help us. And you always start with saying "when clicked." Okay. Now, yeah, before getting into that, there is one small concept called text training, as you can see here. So I have to tell the computer that if COVID positive, or if it is COVID positive, then there are these symptoms. For example, fever is a symptom. I think cough is a symptom, then sore throat, something like that are symptoms. And if I have to tell the computer that it is COVID negative, then I have to tell the computer that I am wearing a mask, or maybe I'm doing hand sanitizer, I'm sanitizing my hands, or washing my hands, or I'm doing a quarantine, or I'm maintaining social distancing, all those things, right? So the computer first has to understand that this is positive, this is negative. And that is where the concept of text training comes into place. So I will show you a model that I have trained. So if you are planning to do this, you will have to click on this. You just take this, and then it is going to ask you for the key. And for the key, you can use this link. I'll ping this link again as on the chat. Okay, so what this link is going to do is, oh, sorry, this is again this link. Sorry, this is the second link is the right one, not the first one. My bad. Okay. Now, what I'm going to do here is I'm going to teach the computer that this is COVID, this is positive for COVID, this is negative for COVID. Very simple. Okay. So what I'm doing is these are all the first time things. So if you click on sign up, you will get it. This is how I am teaching the computer, or I'm telling the computer to learn that this is positive. So I'd say if I have chest pain, loss of taste, headache, conjunctivitis, diarrhea, sore throat, aches and pains, tiredness, dry cough, fever, these are all symptoms for COVID positive, or these are all possibilities that you might have COVID positive. And similarly, if I want to say it is COVID negative, let's say I'm staying indoors, I might not have COVID. If I do hand wash regularly, if I'm feeling normal, if I've done quarantine, if I've done isolation, if I've done proper sterilization, if I am clean, like my surrounding is clean, if I maintain distancing, if I sanitize regularly, if I wear a mask. These are all possibilities that it is COVID negative. Okay. Again, we are not confirming anything. As you all know, we are trying to tell the computer this might be a possibility for COVID. Then you just click on train over here. I think the button will be train. And once you have trained it successfully, if you click on go, it will again take you to this link. So these three are the very important ones for getting started with the code. This will be called your read key and write key. So if you click on sign up, the other link will come and you'll have to put your name as well. So my name is Ajay Dia. I'm putting that. Maybe I'll show you the code that I have done. Okay. So what I do is I'll have to set all three: read key, write key, and username. These are all just one-time things, so I will not ask you to worry about this. The main thing is the assistant. Okay. So you take the read key, put it over here, then the write key. Now, what we want the computer to do is the computer should first ask the user, hey, what is your symptom? That is the core part of it. Okay. So you go inside sensing and you say, you check this box answer, ask and wait. Okay. So the computer is going to ask, what is your symptom or action? Okay. Because the training that we have given is for both symptoms and actions. So this again is not applicable only to COVID. You can do it for any kind of pre-check that you want to do. For example, you have seen a hospital where you want to decide if a patient has to be an inpatient or outpatient. It is applicable over there as well. So you just tell the computer that these symptoms mean inpatient, these symptoms mean outpatient. And the computer will do it for you. So you ask the computer, and then the computer is going to give an answer which will be stored in the form of answer. You just click on this checkbox. Then we have a variable. Okay, so we are going to use this answer and compare it with the with what we are getting. Okay, so let's say we put action as the name, and we are going to say set action to answer. So you're going to use the word action to map your answer. Okay. So need not worry about how complex this is because it is very simple and this is not the objective of our thing. I'm just giving you an overview. Okay. So what I'm going to do is again, there is a small block called if, and inside the if, I'm going to say if my action. So my action is the input that I have given. Okay. And then you go to text training. Okay. Okay. So you see this very particular important thing. What kind of phrases answer? Now this is the part, or this is the phrase which is going to identify your result. So you have to put action. Actually, action should be this. So you're telling whatever input that the person is giving, find out if it is positive or negative. That very important phrase is this. What kind of phrase is answer? Okay. And if answer is positive, you just go and say positive. This is the basic structure. There is nothing more complicated than this. Okay. So you run on this, it will ask for your action or symptom. If I say fever, oops, there was some error. Okay, I think there is some error, but this is the, I mean, it's actually the same code. I think my classifier might have had an issue. So this is how you can design your own very simple assistant to start with healthcare. And how or why IoT is used over here is because this kind of assistant you can create at one place and use it for many different applications. For example, you create this this assistant and you upload it on the central server. Any hospital that wants to do it can take it, because this is very common, right? The symptoms for corona, positive, negative, all those things are very common, and multiple hospitals will want to use it. That is where IoT comes into the place. Okay, so I think I'll pause here and see if my teammate Anish is joining. Any questions? I mean, has Anish joined? Let me see. Oh, okay. Anish has been.
There is a question, sir.
Yes. Sorry.
They want to know how. The question is from Jayanti E. How to read the full report?
Jayanti, I'm not very clear on the question. Which full report are you referring to? Can you elaborate? Pramod's question, yes, this is a Scratch program. So it is another software called Cognimates. But yeah, it is a Scratch program. Jayanti, please elaborate what report you're referring to. Yes, sir. Okay, so you're asking in this chatbot how to read the full report. Like, you want to read if if it is positive or negative, and then you're looking for some other information, right? Like, for example, go to the doctor, something like that. Is my question right? Because this chatbot is designed to only give the user, hey, this is positive, you have to go to the doctor, or this might be positive, you have to go to the doctor, or this might be negative, you're chill. Okay, I'll show you again. So I'm explaining the flow of this working chatbot over here. First thing is maybe a welcome message, because assistant that you see out there has to welcome the patient. Then you ask what is your name, and you say hi followed by the name. Okay, so till this step it is all not needed or something like that. Okay, so this thing I forgot, this one line I missed. That is the reason it did not work over there. Maybe I will. Okay, so these 4 steps are very important. The first thing is you are setting your read key, you are setting your write key, you are setting your username. This step is what I missed when we were trying out. So this is called choose text model. So in your username, my username is Ajay Dia. I can program lot of cases like this. For example, I can program a tester for COVID. That's what I have done. As I was explaining earlier, I can program another simple test that will identify if it is an inpatient or outpatient. That is, let's say, hospital check. It is called, the model is called hospital check. This model is called COVID. So you want to tell the computer which model you want to use. That is why I'm using COVID over here. Then this peak is again of an added functionality so that the user can interact with the computer. You ask the computer, please tell me your actions or symptoms, and wait. This is the most important step. Set result to, or set the variable. Okay, the variable that I have here is called result. So set result to what kind of phrases answer. Now, what kind of phrase is available in this one? I'm sorry, my bad. It is available in text training. This, as you were asking, is the place where this report goes and or it gets fetched. So, as you were seeing here, if at all it is one of these 10 words, the result or the report should be positive. If at all it is one of these 10 words, the report should be negative. So that is what this step does. What kind of phrases answer? It is very, very important. What kind of phrases answer? You take that and assign it to a variable called result. Then it is only simple checking. If result is positive, you say so and so. If result is negative, say so and so. And inside this, you can put your message like, if it is positive, we are saying, oops, there are symptoms for corona. Please go for COVID test. Similarly, if it is negative, we are saying it's negative, but still we want the patients to take care. So we are saying, please take care. So did that answer your question?
So there was another question from the Jayanti ma'am. So ma'am is asking whether the chatbot can be able to use anywhere or it is only meant only specifically for healthcare.
Okay, so this particular chatbot that we are doing, ma'am, is for healthcare because of our classifications. Okay, I'll share my screen again to answer this. So where you are going to use this chatbot is very much dependent on this thing called categories. So these categories we have created are positive and negative. Now, so this is meant for only healthcare or only COVID. If I want to create another category, let's say you want to, I'll give you another example. Maybe I want to book ticket categories. Okay. I want to identify an animal. Okay. I want to identify an animal. This is used in maybe a pet clinic or something like that. I want to identify an animal. So I will have a category called dog and I will enter words like bark, bow, then what, big, pet, something like this. And this category is called dog. And this will be used in some other industry, like for example, a pet clinic. So it all depends on the categories that you define over here, where this chatbot is going to be used. So if you're having categories like dog and cat, that chatbot is used in some other place. I hope that answered your question. Okay, thank you. Any other questions?
Sir, I have a question, sir, because
Yes.
it's something based on the video which you have run.
Yeah.
I don't know whether it is a right question or not, because since we said it is a cloud access is there for an IoT.
Yeah.
So it's not that attackers will be there to alter the data, because we have both passive and active is there. So how to prevent these sort of an attacks specifically? Because when it comes from the healthcare, it is supposed to be the most important factor. Everywhere I have to
Right.
make a sense of it. It should not have any impact on others whenever I'm going for a checking it up. How to prevent those sort of
Exactly.
an attackers?
Exactly. Excellent question, sir. As you mentioned, since the data is coming from healthcare, this is kind of the most sensitive or most important information. Very simple solution that I can think of how you can prevent is cryptography. So let's say you have a simple data. What time do you get up in the morning? And if that answer or if the data that is stored in says 6 a.m., if you want to modify that data, if an attacker goes it and changes it to 7 a.m., that's a very basic example of an attack. If I want to prevent or if I want to save this 6 a.m. in a confidential way that nobody else can access, then I can do an encryption. As you know, cryptography is the field for it. So the 6 or whatever the data is over there will not be the same for all the users. So only whoever has my password can use this and find it that it is 6. If someone doesn't have my password or so it's again a very big field called cryptography, how you encrypt the data and all. It is similar to storing your password. So your password will not be visible on screen, right? How you store the password, only you can see it if you click on the show password. Similar to this, we can even if some attacker gets, they will not be able to make out or they'll not be able to see the data. And obviously, to prevent them from changing the data, the access, as we call it, access or the who all can access the data, that will be restricted. So typically what kind of security people do is read access is given for everyone or almost everyone. Write access, as we call it, is restricted to only, I think, only the user or only the person who uploads the data. So those are the two things that I can think of as security solutions. Any other questions? So if there are no questions, I think we are good then. Sir, you're on mute if you're speaking.
Okay, I'm sorry. No, sir, I don't. I just got the answer from your for the question which I've asked you. And I think one of a ma'am has raised her hand. So,
Yes, I was also seeing the same. Do they have?
Rajeshwari ma'am, do you have any question, ma'am? Ma'am, Rajeshwari ma'am, do you have any question? Sir, what will be the future of healthcare industries?
So the way I see it, the future of healthcare industry is a situation where now similar to this famous concept called work from home, treat from home. That is what I see as the future. You sit in your home, you're able to diagnose and all those things very easily from home only. And if it is a simple treatment like just getting a small pill or taking a small physical change, it is possible. Except for very crucial surgery level things, you might not have to step out of your home. That is what I see as the future.
Sir, do you think that it will have a good, we have a good research in the future with respect to our healthcare?
Yes, because the reason why I think it will be very positive is these technologies that I was talking about. For example, you take remote surgery. It was developed way back in 2001. And even till today, we have not seen, I don't think any of us has seen a remote surgery or been a victim of remote surgery, right? Because it has been 20 years, and the reason it has not come into the market is there are so many security and risk factors that are there which are being analyzed. And if a technology like surgery is taking 20 years to come, I am pretty sure that it would have gone through at least 1,000 different ways of checking, and by the time it comes to the market, it would be risk free. So this is what I see as the future, because it is, since it is taking time, it will surely be risk free. And if it is risky, I don't think the government will take the courage to approve it. That's, I think, the answer to that. Yeah, as you all know, there are many technologies that have been proposed that have been proved, but the reason why they're not in market is again approvals, and that is for risk analysis. So only if people are very sure that it is 100% risk free, it will come into the market.
Sir, do you think that is it good enough for the institution to invest in doing a research in IoT with respect to
Yes,
any industry?
of
I mean,
course.
application may be a different. It's not only in a health industry. It may be for a safety precautionary methods, or it may be there in the transportation, or it may be there in the trafficking system for a, because right now we have been getting a news that so many newborn childs have been trafficking somewhere else from the hospitals. It's quite common right now in Chennai. So I'm
Right,
hearing
right,
a
right,
news everywhere, and then it is there. Do you think that it
right,
is
right.
good enough to invest in the research with respect to IoT? The reason why I'm asking this question is we are taking up from KCG, we are developing our IoT lab. We have received a fund from AICTE, so we want to continue with the research in that IoT lab. That's why reason I'm asking you this question, sir. Do you think that it's good enough to continue? Because we have so many domains are there when it comes for an IoT. So like what you have given us, like a healthcare or transportation, trafficking, which will be the brightest future in the past, in the future? so that we can invest and gain?
Okay, so to answer your question, I'll come back to today's COVID world. How the world works is how it worked pre-COVID is everyone could travel everywhere, everyone could be in different places, and that is how people got work done. But ever since COVID has come in the world, people are trying to do everything remotely. For example, work from home is a very common one. Then imagine what if a traffic police thinks of the concept of work from home. It could be possible, right? Like the traffic police sits at his home. Instead of the traffic signal, he fixes cameras all around the traffic signal, and he's continuously monitoring the road. That is, I think, more than enough. A 360-degree view is more than enough to monitor and switch left or sorry, red or green or yellow, something like that. So if a traffic constable's job can be done from home, then that is possible through IoT. And I think it is surely worth investing in such industries where you have a very bright future. For example, the example that I gave you has a very certainly possible future. But there are again certain areas where it is certainly not possible. For instance, something like a travel or a theme park experience. Though you might have a solution using IoT, like you can simulate your own, let's say, water slide at home, it is not going to give you the experience as going over there. So there are certain fields or certain ways where IoT can be used and it is worth to invest over there. There are certain other areas that it cannot be. So if you can identify these areas where the future is there or where you imagine, just imagine the person sitting over there, just imagine what will happen if they go away. If you think that there is a future without the person over there, with just a computer or robot, then it is surely worth investing in that domain. Again, there are a variety of domains, so we cannot cover everything.
So because we are moving towards an automation world.
Yes, yes, yes.
So do you think that automation can sustain the work environment of what human being we are doing?
Yes, I
Because
think
there is a
it
talk is
can.
going on there everywhere. If automation
Right.
comes into picture, we may not require any human intervention will not be there, specifically when it comes for a teaching field.
Right, exactly. So I think that it can be there. The only place where automation will fail or will be not helpful is when a very strict human intervention is required. For example, let's say I'll give you the example that you were talking about, so teaching. When I am trying to teach a student online, and if the student understands English, it's good. But I have myself taught students who are not able to understand English very well. So how they communicate with me is they show me their actions and they type on the screen or they try to draw what they're trying to say and show me saying, this is my question, can you please answer this? And how I say again has to be changed in a way that they understand. So there are certain uh, corner places, that's what I would call it, where human intervention is still required. So those things will not be possible in an automated world. But apart from that, the basics, as you can see, is surely possible. All the core basics is possible.
Thank you, sir.
So I think Anish will not be joining, so we can wind up.
Okay. So participants, is there any question from your side?
There is nothing.
Is there any question is there from your side? Sir, 1 minute, sir. We'll give them a time. Let me find whether they're giving any question or not.
Sure, sure.
Just a minute. So, is there any question from the participants? Okay. Since there is no question, sir, it is really we'd like to thank you for spending your valuable time and presenting your the thoughts on the health industry. I think you hope the participant might have got benefited. And once again, thank you, sir. And thanks for the participation from the students as well as the faculty members. Hope you join back by tomorrow morning. Thank you, sir. And thank you, participants.
Thank you.